I think, a much richer understanding of who Hans Alfven was, as opposed to plasma cosmology pages and Wikipedia pages. They don't really do him any justice. In other words, they don't relate who he knew, who were his influences, who he influenced, as well as where his ideas were coming from, who he was talking to, how they interacted with him, that kind of stuff. So I'm going to link this to the bottom of the video. It's written by Bibas Day. I'm sure somebody else has heard of him. It's written May 30th, 2008. It's a pictorial tribute. It says, remembering a great scientist, a genuine humanitarian, and a remarkable human being. And there are a lot of ideas in here that I want to go over. Hans Alfven lived from 1908 to 1995. So he was inside of that time frame of all the other scientists when they were doing their thing. So we have here a lineage of Alfven's teachers. They're on here. As well as I even has a picture of him reading a children's book on popular astronomy by Camille Flammarion. It says here, according to Hans' own account, 2 childhood experiences had a significant influence on his intellectual development and scientific career. One was a book on popular astronomy by Camille Flammarion, which he was given at a young age and which kindled a lifelong fascination with astronomy and astrophysics. The other experience was that he joined the school's radio club, where he was an active member and built radio receivers. This instilled in him a profound interest in electronics. Therefore, as a scientist, Hans was inclined to look at astrophysical problems from an electromagnetic point of view, and this turned out to be very fruitful. When his book Cosmical Electrodynamics was published in 1950, one of the reviewers, T.G. Coling, referred to him as an electrical engineer in Stockholm. He even has a picture of some things he was doing as a 15-year-old. They were much more advanced than the things I was doing as a 15-year-old, of course. Probably I don't really remember. I guess I was learning geometry and algebra and that kind of stuff. And even has a picture of when in 1934 he was awarded his doctorate. And there was only one other doctorate of physics in this picture. I guess the others were economics and literature and things like that. And the remarkable encounters that he's had, the people that really influenced him and made him think about where his life was headed. It says here, in his meeting with Arthur H. Compton at a conference in London about 1934, which was the same year he received his doctorate, they discussed Alfven's recently published papers on cosmic radiation, a paper which Alfven himself was not happy with. Compton said, quote, "Don't give it up too easily," end quote. Later, Alfven was to write about this meeting, quote, "As he was one of the great authorities on cosmic radiation, this was an enormous encouragement to me. In retrospect, this may have been the trigger which brought me into astrophysics. It happened at a time when almost everybody was running towards nuclear physics. It saved me from the guilt associated with atomic bombs and nuclear energy, which every nuclear physicist of today must feel at the bottom of his heart," end quote. I wanted to point that out in specific because everybody was running towards nuclear physics at the time. And they were also building more powerful telescopes. So the development of nuclear physics was going hand in hand with telescope power. So they could see further and further out into the universe, and we can understand more and more about the nuclear structure of atoms. Unfortunately, because of so many people going into nuclear physics, and them realizing how much power was associated with it, they misapplied the nuclear physics to stars, which are gravitationally collapsing nebulas that are electromagnetically influenced. They're not nuclear, they're electrochemical events. So you have a complete denial of the actual structure of the sun and how it actually works, because when people were learning about nuclear physics, they were applying nuclear physics to everything. So you look at the stars, look, they're power nuclear, and this is power nuclear, and that's power nuclear, and they weren't really looking at the objects for what they actually were. They had in their minds what was true, and then they applied it to everything else, and then the rest is history. So now we have the sun as nuclear powered, even though it's not nuclear powered at all. I just wanted to point that out. It's something I noticed. It was the paradigm. Everybody adopted it, and then nobody asked any questions. They rolled right through it. Let's see. That one didn't stick out to me. Here's another thing that stick out to me, because my degree, eventually when I get it, is in just human communication. And a lot of the arguments the EU presents, Electric Universe, is the idea that scientists, they just look at magnetism as being the only real dominant thing if it's due to, or inside of the cosmos as, as an important pushing force or whatever, other than gravity. And they don't look at electricity and electrical current and that kind of thing as much as they do magnetism. And I found the reason why, and it says here, it has a picture of Lord P.M.S. Blackett, a Nobel Prize-winning British physicist. It says here, Hans Alfven discovered and laid down the foundations of the science of magnetohydrodynamics. The subject combines the complexities of electromagnetism and hydrodynamics. Thus, in shorthand, electromagnetism plus hydrodynamics equals magnetohydrodynamics. In 1948, Nobel laureate in physics, Lord Blackett, used to express this to his students as follows. Quote, electromagnetism is difficult, hydrodynamics is very difficult, but magnetohydrodynamics is damn difficult. End quote. Now, I'm not too sure if people understand language too well, but do you see what happened there? They took electromagnetism and hydrodynamics and they make it magnetohydrodynamics. They completely cut off the electro word. Oops. So what that does is it takes language and it says, well, this is what it is. Yet the very concept of MHD includes electrical current, electrical charge, and electricity in general. So they cut it off completely from the very beginning from language alone. Language alone ruins people's ability to perceive what kind of phenomenon they're studying. And this is why it's very dangerous to give things names that are untrue or half-true, because inside of the name you give something, you have the understanding right off the bat. For instance, you have the theory I'm developing, stellar metamorphosis. The reason why I chose metamorphosis is because the evolution of a star itself leads to life as the elements combine into molecules, and the molecules get more and more complex as it goes on down the line and the star cools. So to use the word metamorphosis versus transformation, transformation sounds cold, inhospitable, more mathematical, more, oh, this is a graph over here, a graph over there, here's a formula here, a formula there, and basically not really connected to life in general. So I thought to myself, well, if I name it stellar transformation, the concept of life is still going to be kind of out there in outer space, and then it comes here. No. By naming it stellar metamorphosis, we have a metamorphosis of the entire structure to the point to where it changes in ways we never would have perceived before. Like a caterpillar becoming a cocoon and then becoming a butterfly. it would be a completely unexpected change. I mean, how weird is that? This little multiple leg creature walking around that has a really fat, thick body, eventually becoming something that flies around and has huge, beautiful patterns on it. Like, who would have thought that was possible until we actually saw it happening? It's like saying, well, the cat's going to curl up into a ball, start morphing into this crazy looking eagle. It turns into an eagle. Like, what? Cats turn into eagles? That's impossible. But that's basically the same thing as what happens to a caterpillar. It becomes something completely different. It undergoes metamorphosis. But I would go over a lot more, but this video is really long. I do want to post this to the bottom of the page and really get people to think about these things. Really get them to question a lot of the language problems and to look at people not as isolated systems. Like you talk about Hans Alfven, but you got to realize that this person over here influenced him, this person over here influenced him, this person down here, his parents are over here, some of his close friends are over here, his wife is over here. You know, you have to look at people as a giant web of influence. And from that web of influence, you can get where he was going and what made him to be who he was and where his mind was as well. Because people, they tell you ideas over and over and over again, and you tend to adopt them over time, and then you act on those ideas. Alright, well, today is August 14th, 2015. Everybody, take it easy.